Hi, welcome to the video solution for physics past paper solution. This is Edexcel GCE Unit 3, January 2013. Those students who are giving IAL WPH 03 also can take help from this paper. So let's start. Question number 1. Which of the following is the SI derived unit of frequency? Frequency, the unit is Hertz. So option is B. A graph is plotted with the velocity on the y-axis and the time on the x-axis. Which of the following would represent the distance traveled? So the graph between velocity and time, whatever the shape of the graph is, it may be a curve or maybe a straight line. It depends on the types of motion. If you need to find the distance traveled, so you need to find the area under the graph. Area under the graph represents distance traveled. So your option is A. In order to find the distance traveled, you need to find area under the graph. And if you find the gradient of the graph, so gradient gives you acceleration. But in this question, they are asking you the distance, so it is area under the graph. So option is A. Question number 3. In an experiment to measure the breaking stress of a wire, the diameter of the wire is measured with a micrometer. Which of the following procedures would not be good practice? Checking for zero error, yes, it is a good practice. In order to reduce or in order to check the systematic error, so it is needed. Repeating reading 3 times, yes, it is needed because of using mean and to get reliable result. Rotating micrometer between reading, this is also a good practice. Using a second piece of wire to check the diameter, no, it is not a good practice. So we'll have to use only one sample to perform any experiment. So the option is D. It is not a good practice to change the wire. Option is D. Question 4. The diameter of the ball bearing is measured 4 times. The measurements are 0.27 millimeter, 0.29 millimeter, 0.25 millimeter, and 0.26 millimeter. How should the average value be stated? It's all about taking mean and average. If you see, we have a data set with 4 values and all values are close, so we don't need to see anomalous reading. There is no anomalous reading, so we find the mean of all the 4 values. So 0.27 plus 0.29 plus 0.25 plus 0.26 and divided by 4. If you do that, the mean value you will get 0.2675. You round it off 0.27. So your option is C. Question number 5. The graph shows how extension varies with applied force for a spring. This is extension on y-axis, applied force on the x-axis. Which of the following is energy is stored in the spring in joule when it is extended by 6 centimeter? We need to find energy stored from the graph, and this is force extension or extension force graph, and energy stored is area under the graph. This is energy stored. So how much extension is there? 6 centimeter. So okay, that means the whole area. So you need to find whole area of the graph. That means energy is half into base, and base is 9 into height. Height is 6. In fact, remember the height or the extension is given in centimeter, so you must convert this 6 centimeter into meter. That means 6 divided by 100. So you can change 6 centimeter into meter. That means 0.06. When you multiply these numbers, you have energy stored, and this energy is 0.27 joule. So option is D. Question number 6. In an experiment to determine the acceleration of free fall, a metal cylinder is dropped from rest down a glass tube. A light gate is positioned close to the outside of the glass tube. Okay, the light gate measures the time taken. Okay, the cylinder to pass through it. The time t is used to calculate the velocity of the cylinder at a distance s from the top of the tube. The student varies the position of the light gate and records t for different values of s. Suggest what the student should do to obtain accurate value for t. So in order to get accurate result, a student should try to release the cylinder with the rest position, so that we can take initial velocity as 0. And also when you drop the cylinder, then make sure that the cylinder does not touch the wall of the tube. This is second. And you can also say that you can repeat the time to use the measure to use the mean value, so you can get a reliable result. So make sure that you have initial velocity 0, cylinder does not touch the wall. You can repeat the reading. B, the student needs to determine the velocity v of the cylinder as it passed through the light gate. State what additional measurement she needs to make. You may add to the diagram if you wish. So this is the diagram, and it is a need to determine the velocity of the cylinder. So velocity of the cylinder as it passed through the light gate. So when the cylinder passed through the light gate, when the cylinder is passing through the light gate, that means if you wish to find the velocity of the cylinder, so you need length. That means you need length of the cylinder, because this length divided by the time noted by the timer. If you divide this length with the time, you can have a velocity. So you need length of the cylinder. State how she would use her measurement to calculate V. Definitely length divided by the time from the timer. You can find the velocity. To determine G, the student uses the equation V square is equal to U square plus 2AS. Explain why a graph of V square on the y-axis and S on the x-axis should be a straight line through the origin. A student is using V square is equal to U square plus 2S. So as the cylinder is being dropped from rest, that means initial velocity is considered as 0. So if initial velocity is 0, then the equation becomes V square is equal to 2AS as U equal to 0. And then you can compare this equation with y equal to mx. That means m, which is gradient of the line, and in this case if you compare, the gradient would be 2a, which is a constant. That means v square is proportional to the displacement. That's why the graph between v square and displacement or a distance is a straight line passing through origin, because y equal to mx, this is the equation of a line passing through origin. Use the student's graph below to find the value of g. So this is a graph. You need to use the graph to find the value of g. So idea behind finding the value of g from the graph is, if you see the equation, v square is equal to 2as, and if you make a as a subject, so a is equal to v square upon 2s. Moreover, if you see v square over 2x, v square over s, this is the value of the gradient from the graph. That means gradient from this graph, because you see it, the vertical axis is v square and the horizontal axis is s. So v square over s will give you the gradient. That means we find the gradient of the line, and the gradient is divided by 2 can give us acceleration. So the only thing, we need to find the gradient and make it half. So how do we find the gradient? We choose 2 points and we make a triangle, and we find the gradient using rise over run, or y2 minus y1 divided by x2 minus x1. So these are the 2 points I am choosing here, and these are the coordinates of the point. If you wish, if you want to show, you can show the triangle from these points. In fact, this vertical line is considered as rise, and this horizontal line is considered as run. So the rise is 16 minus 5 equal to 11, and this is y2 minus y1, and the run is x2 minus x1, which is 0.58. So you can say that the gradient of the graph is rise, which is 11, divided by run, which is 0.58, so 0.58. If you divide these two, gradient would be equal to 9.5 meters second minus 2. And I'm sorry, this gradient 11.5, yeah, no, is this gradient will not be 9.5. The gradient, when you divide this, because this gradient is double of the acceleration. If you see the equation, v square over s is equal to 2a. So the gradient is double of the acceleration, so it should be double of the acceleration. So it is around, if you use your calculator, so 18.97. This is the gradient when you divide these two. And then acceleration, or the value of g, is the value of the gradient, make it half, divided by 2. So g, you will get 9.5 meters second minus 2. The student's value of g is less than the accepted value of 9.81 meter per second square. Suggest why. Of course, it is possible that there is air resistance involved in the experiment, which causes the acceleration, the calculated acceleration to reduce by some amount. Also, there might be a collision or friction between the cylinder and the falling cylinder, and this 9.81 is this accepted value at sea level, and the student might be doing experiment somewhere else where g is different. So there are many possibilities of this difference. So some of these are, so you can write these reasons of this difference. Question number 7. A manufacturer states that a solar cell gives an output of 5 volt and 100 milliampere. An experiment is to be carried out to check the EMF and determine the internal resistance of the cell. Write a plan for this experiment using standard laboratory apparatus and a graphical method for analyzing the data. You should draw a diagram of the circuit to be used and list any additional apparatus that might be required. So in this experiment, because we need to find EMF and the internal resistance, so basically the idea behind EMF internal resistance is the equation E is equal to V plus IR, and in this equation voltage and the currents, these two are variable that we are going to measure. So in order to measure the current and the voltage, we need ampere meter, we need voltmeter, because we need to change the voltage, so we must need a variable resistor and a solar cell. And the symbol of the solar cell is this: one small line and the one big line in a circle, and you can make arrows coming inward. That means this is solar cell. So you need these 4 equipment for this experiment or this investigation, and you need to join these in a circuit. The idea is the voltmeter is always connected in parallel with the component being studied, and rest of the component are connected in series. So you can start your circuit like a solar cell, connected with the ampere meter, and then ampere meter is connected with a variable power supply, and then make a closed loop or a series, and then the voltmeter is connected parallel to the solar cell. That's how you draw the circuit diagram, and your additional apparatus is variable resistance, which are not mentioned anywhere here in the question. So the additional apparatus is the variable resistance. State the quantities to be measured. Of course, it's a voltage and the current that we are going to measure, voltage and the current passing through the solar cell. For each of these quantities, state and explain your choice of the measuring instrument. The measuring instrument for voltage, we use voltmeter, and for current we use ampere meter. And the choice, why is that? Because if you're looking at the range, so voltmeter should be greater than or equal to 5 volt, and the ampere meter should be range of more than 100 and equal to 100 milliampere. So voltmeter range more than or equal 5, and ampere meter range more than or equal to 100 milliampere. Explain how the data collected will be used to determine the EMF and the internal resistance. In this case, because we have a data set for voltage and current, so we are going to plot a graph between voltage and the current. Voltage is on the x-axis, voltage would be on x-axis, voltage is on the y-axis, current is on the x-axis, and we can expect a graph like this, and this is called y-intercept, and this y-intercept would be your EMF. And if you find the gradient, so the gradient will give you internal resistance, negative of the internal resistance. So negative gradient equal to negative R. So in fact R is the gradient of the graph. Identify the main sources of uncertainty and or systematic error. So if it depends on the type of equipment, if we are using analog meter, and the analog meter is, whether it is a voltmeter or ampere meter, is a meter consists of a scale like these, in which we have a needle and we measure, and this is, we have some scale here, and this needle rotate left or right according to the voltage and the or the current passing. That means we need to read the reading with our eye. So there's a chance that we have a parallax error if we are using analog meter, and if we are using digital meter, so we might have a systematic error or the zero error in the instrument. So keep intensity of the light, okay, intensity of the light should be constant. Sorry about this English. So the intensity of the light should be constant, and turn off switch between the reading, so that okay, I guess I missed the part E. Identify the state, how to control the other relevant. Okay, fine, yes, the other relevant variable is intensity of the light, because we are studying change in voltage and the current. So if intensity is not constant or does not remain constant, then the variation of the voltage and the current might be due to the intensity of the light, not due to change in the voltage. So in order to do a fair test, intensity of the light should be constant, and we make sure that the temperature also remains constant, so we can turn off the switch between noting down our reading. And this is part E, and I was just talking about part F before because I just missed E. Now F is main source of uncertainty. It's all about parallax error and the zero error. Okay, comment on safety. Of course, it is involve a low voltage, so there's no such risk of getting shock or such thing, but there's a chance that some component gets hot, so we should take care of when we about to touch the equipment. Okay, a group of student is asked to determine the unknown concentration of sugar solution by measuring the rotation of the plane of polarization. The students have taken the following measurements using known concentrations of sugar solution. So this is concentration of sugar solution in percentage, angle of rotation in theta. So these are the percentage of concentration and the rotation. Okay, so criticize these results. Again, less number of reading, no repetition. We cannot include the inconsistent significant figure because they are using according to the significant figure. So we cannot include, or we cannot say the inconsistent significant figure. So don't write that about the significant figure. But less number of reading, no repetition is there, and if you see the interval between consecutive readings are not equal, so unequal intervals are being used. So you can write like these. Oops, again, it is not 5. It's not necessary that you mention. If you mention, this is okay, but if you write less number of readings, it's sufficient. You want to write, you want to mention, so there are 1, 2, 3, and 4, so you can say the only 4 readings, and which is not sufficient for the purpose of graph. But no, okay, but it's fine, and no repeated values and unequal interval. Plot the graph of the angle of rotation of the plane of polarization against concentration. So concentration is independent variable, should be taken on x-axis, and the angle of rotation on the y-axis. So that's how we choose the scale, so we can cover more than 50% area of the graph, and then we plot the corresponding points. These are the points. So this is point, this is your first point 0, 0, and the second point, third, and the fourth, and this is best fit line. The student measure the angle of rotation for unknown concentration of sugar solution as 20 degree. Use your graph to determine the value of this concentration. This is the graph that we plotted, and angle of rotation is 20 degree. So this is 20 degree. So we need to find corresponding concentration. We draw a horizontal line till best fit and then bring it down. It is 25. So you can say that this is the corresponding values of the concentration. So at 20 degree, the concentration is about 25%. That's it for this video. Thank you very much. Have a nice time.